Hey everyone, and welcome back to another exciting video devoted to the Sports Hub portal. Today John and I are going to unpack something called architecture vision. Don't worry, it's way less complicated than it sounds.
Architecture vision? Is that like a superhero thing?
Not quite. By the end of this video, you'll get what architecture vision is all about, why is architecture vision important, and what key decisions and plans go into it. And guess what? We're going to use the Sports Hub portal as a real-life example. That's the product you guys already know and like. We'll show you the main goals of the solution, the big features, and the design limitations. The whole picture, and how the solution is broken down into 3 levels of complexity: basic, medium, and hard. And lastly, the operational plan, which is a practical document that lists the key activities and targets. Lots to cover, so let's get started.
Okay, but first, what exactly is architecture vision?
That is a good question. Think of an architecture vision as the blueprint for a big project, for example, a software application. It's the first step where architects plan everything out, making sure it matches what the business needs and aligns with the business goals and the strategic drivers, but also sticks to the principles and addresses the concerns and objectives of the stakeholders.
Okay, I get it. But what exactly is in this document? Are there any specific sections?
Absolutely. The process kicks off once the client provides all the needed requirements: business, functional, non-functional, including any limitations. Armed with this information, the architect can start crafting the architecture vision. This document lays out the single-entry architecture for developing the solution. To give you an idea, here's what the architecture vision document typically includes: the main architectural drivers guiding the solution, the proposed software architecture of the solution based on the drivers, definitions of the technology stack and environment, operations-specific perspectives, and lastly, the development roadmap, including high-level estimates for effort, team size, and required skill sets. Additionally, the document highlights key architectural decisions and identifies business and technical risks related to implementing the solution. Now, let's dive a bit deeper into key architectural decisions and risks. So, key decisions give us an overview of the most important tech stuff and services we need. Imagine, for example, deciding to build our Sports Hub portal as an online cloud service. We would choose a platform like AWS or Google Cloud to host it. This could also involve making sure our data is safely stored and easily accessible, and maybe even pulling in sports news from other websites into our own system. Now, let's talk risks and open issues. Key risks are basically real risks that are related to the solution design and implementation, while open issues are the issues where architectural decisions have not been made yet or are likely to change. Here, in the example below, you must note that when we provide a risk description, we should also think of the possible ways to mitigate it. Alright, let's now chat about another key part of architecture vision: architectural drivers. Think of these as the essential elements that guide how we build our solution. This includes all sorts of requirements: what the business needs, how the app should function, and even things like speed and security. These are all detailed in the document. However, some requirements don't really affect our big picture plans. Those are usually left out of this section and go into something called a product backlog, which is essentially our to-do list.
Wow, that's a lot to take in. I can't wait to see how all this theory works in real life.
We're just about to get into that, using our very own Sports Hub portal as a real-world example. Let's take a closer look at how this all works, particularly focusing on our news aggregator feature. The goal of our Sports Hub portal is to make it super easy for users to check out all the latest sports news, whether they're on their computer or mobile. Users can access fixed common news, benefit from subscriptions, immerse in interests and personal news, as well as customize their news feed, subscribe to their favorite topics, and even get regular newsletters. And rather than having to visit multiple websites or apps to stay updated, users can simply rely on our aggregator to provide all the relevant news in a single, user-friendly interface. But the best part is it's all going to be available online, thanks to cloud computing platforms like GCP, AWS, or Azure. This means users can access the portal anytime, anywhere, as long as they have internet.
And what about business goals?
So, the business goals section of our architecture vision document lists the primary goals we're aiming to achieve with this solution. For example, one of our main goals is to create a sports news platform that offers flexibility to users, allowing them to personalize news, subscribe to newsletters, and access the platform on web or mobile devices. Let's now move on to the next section called Major Features. It outlines the key functionalities of our platform, such as reading news related to different kinds of sports, subscribing to the sports news of their choice, receiving newsletters via email, managing the kind of news they want to see, and allowing admins to define or modify the structure and content of the portal. Also, the document includes design constraints, which are limitations that the solution must adhere to, like supporting a minimum of 1,000 simultaneous users and being cloud agnostic to simplify migration to another cloud provider.
I also see that there is a section in the architecture vision named Quality Attribute Scenarios. Sounds complicated to me. What's that?
It might sound a bit complicated, but is actually quite simple. It involves defining the quality attributes, which are measurable or testable properties of the system, such as security, usability, and maintainability, and then outlining scenarios to evaluate the system's performance. For example, a scenario for the performance attribute could be that the application's first page upload time should be less than 2 seconds.
Great! Now I get it. I am excited to see what's next in this document.
What comes next is the primary section of the architecture vision document. It is solution architecture. Earlier in this video, we discussed the concept of architectural drivers. Remember how crucial it is to identify the significant requirements and constraints?
Of course I remember. Identifying key requirements and constraints is super important.
Excellent. Once you have these requirements and constraints identified, you are ready to define the solution architecture design.
I got it. So, what's the next step?
Now, we need to look at the bigger picture, a high-level description of architectural views. These views define the primary solution components and how they interact with external systems and services. Let's consider the solution context for our business case, the Sports Hub. Sports Hub solution is generally responsible for the implementation of all business logic. Identity provider is in control of authentication functionality, and cloud provider oversees hosting of deployed solution. Email provider manages newsletters mailing, while push notifications are responsible for push notification functionality. And news aggregator provides content to portal. It all forms a pretty general picture of our solution architecture. And now it's time to look at solution decomposition, so let's separate our solution into simpler compounds. We've categorized our solution into 3 complexities: basic, medium, and hard. Let's start with the basic view.
What's included in the basic view?
The basic complexity focuses on server-side decomposition. It's particularly relevant for our Sports Hub portal and follows cloud-based architecture best practices. Let's get into some specifics. At a glance, we have various components like portal UI, desktop app, and mobile app for user interfaces. We also have an operational DB for structured data, and services for notifications and email.
Makes sense. But what about the other complexities?
For medium and hard complexities, there are more advanced breakdowns. Here is the medium complexity cloud solution decomposition. And here is the hard one. You can read more about these solution decompositions on our GitHub space linked in the description.
And how about the tech stack?
The development technology stack, a combination of programming languages, frameworks, tools, and databases used to build a software application, may vary significantly depending on your choice.
Okay, that is great. But how will we reach our tech goals?
For this, we need an operation plan, or, in other words, a detail-oriented plan that clearly defines how a business will convert strategic goals to technical ones. Here, for example, you can see our deployment diagrams for GCP, AWS, and Azure.
What about the environments? How many are there and what are they?
In total, there will be 4 environments. The development environment uses minimal cloud resources but similar architecture. Testing environment uses intermediate resource allocation for full QA testing. Staging environment is a copy of production environment and is used for load, performance, and user acceptance testing. And production environment is scalable and fault tolerant. To ensure clarity and optimal data flow, we have database diagrams. These diagrams visually represent the data structure that underpins our portal's daily sports-related activities and interactions. They do more than just paint a picture, they're central in guiding our feature development and addressing any data-related challenges.
Got it. But how do I take part in the project and contribute?
Great question. This is precisely going to be the topic of our next video, which you don't want to miss out on. But for now, check the video description for more detailed plans.
Thanks for the explanation. See you in the next video.